All right, so we're trying to find the antiderivatives of x cubed over root 1 minus x squared. Now let's notice a couple things about this function. First of all, that square root there is really annoying. It'd be great to get rid of that square root. So that's what today's trick will allow us to do. Our integration trick will allow us to get rid of that square root, make a little bit simpler looking of an integral. Something else to notice about our function here. We got to pay attention to the domain. So it doesn't make sense to plug in x values bigger than 1, and it doesn't make sense to plug in x values less than -1. If you try plugging in a number like 2, you'll get the square root of -3 there. Can't do that. If you try to plug in the x value of -2, you'll get the square root of -3 down there. Can't do that. So the domain of this function is x values between -1 and 1. Now, so somebody had this really great idea. Somebody thought, hey, it would be great if instead of having an x there, we had a sine of theta. Somebody had this idea. They said, wouldn't it be great if we had 1 minus sine squared theta under the radical? If we did, 1 minus sine squared is cosine squared. You saw that in the trig identity in the earlier video. Square root of cosine squared is cosine theta. Well, almost. It's actually the absolute value of cosine theta. So remember that the square root of -3 squared would be like the square root of 9. Square root of 9 is 3. So if you take back the square root of something squared, you don't necessarily get back that something. You get back the absolute value of it. So square root of -3 squared is not -3. It's the absolute value of -3. It's plain old 3. Anyway, so some guy had this great idea. Hey, it would be awesome if x was sine of theta. If that happened, then you'd have 1 minus sine squared. Square root of 1 minus sine squared would be square root of cosine squared. And you can take the square root of cosine squared. You have no more square root in the problem. So the question becomes, well, can we just do this? Can we just say let x equal sine of theta? Turns out we can. So if you look at a graph of the sine function here, sine hits all numbers between -1 and 1. So if you pick the right angle for theta between -pi/2 and pi/2, if you choose the right angle, you'll be able to hit any number you want between -1 and 1. So remember, the domain of our function here was x values between -1 and 1. Well, if we choose the right angle between the correct angle between -pi/2 and pi/2, then sine of that angle will actually give you x. So we can let sine x equal the sine of theta, where theta is some angle between -pi/2 and pi/2. Okay, so look what happens if we do this. So I'm going to take derivatives here. I'm going to say, okay, well, dx d theta then is cosine theta. So that makes, if I multiply both sides by the d theta, I have dx is equal to cosine of theta d theta. All right. So I'm going to go back in my integral here, and I'm going to say, okay, I'm going to replace x now. I'm going to replace that with sine of theta. So that's going to become sine cubed of theta. On the bottom here, I'm replacing x with sine of theta, so I'll have 1 minus sine squared of theta. And then dx now, I got to be careful. dx I'm changing to cosine of theta d theta. And what I have now is a trig integral, which you've been practicing on. So I got sine cubed on top. All right, on the bottom, 1 minus sine squared is cosine squared. So I got the square root cosine squared. Cosine theta over here. Now the square root of cosine squared theta in absolute values is left on the bottom. Square root of cosine squared, it's absolute value of cosine, times cosine. All right, now this is a little annoying. We have cosine theta on the bottom, we have cosine theta on top. We'd really like to cross them off, but we can't. This one's inside of absolute values. So we got to ask, well, can we do something about the absolute values? Turns out we can. It turns out we can actually just ignore them. So remember, we're choosing our angle theta to be between negative pi over 2 and pi over 2. Well, think about cosine on the unit circle, using the unit circle. So if you have the unit circle, you have some angle theta between negative pi over 2 and pi over 2. Well, cosine is the x value of this point on the unit circle. Well, if we notice that for angles between negative pi over 2 and pi over 2, the x-coordinate is always positive over here. So in other words, from negative pi over 2 to pi over 2, cosine is always positive. What that means is these absolute value bars here aren't doing anything. Cosine is positive anyway, because our angle is between negative pi over 2 and pi over 2. So we don't need the absolute value bars here. We can just get rid of them. They aren't doing anything. Cosine's positive anyway, and the absolute value of a positive number is a positive number. So we can just do this. And then great, now we can just cross off the cosines. So we're left with finding the antiderivatives of sine cubed theta, d theta. Okay, well, we know how to do this integral. We got to make this look like stuff with cosine in it times sine. So I'm going to pull off a sine here so that I have sine squared times sine of theta d theta. I take sine squared, I replace that with 1 minus cosine squared. And I say, aha, now all of a sudden I can get this antiderivative. I can do a u substitution. I can let u equal the cosine of theta, d theta. And if I do that, then du is negative sine of theta, d theta. So I can take this integral and I can do a substitution. If I do that, I'm left with finding the antiderivatives of 1 minus u squared, and then my sine of theta d theta here, right here, will become negative du. All right. So now this integral is not so bad. All right, antiderivative of 1 will be u. Wait, but I got that negative sign. So I'll distribute the negative sign. Antiderivative of negative 1 will be negative u. If I distribute the negative sign, I got positive u squared here. Antiderivative of positive u squared, u cubed over 3. And don't forget your plus c. Now remember, we're not done. We got stuff with u in it. Well, we started with a problem with x in it, so our answer better have x's in it. So we got to say, all right, well, u, we said u is cosine of theta. So now we've got negative cosine theta plus cosine cubed theta over 3 plus c. And we still got a problem. We still don't have x's in our answer. I mean, our problem started with x's. We need to end up with x's. We don't have x's. Well, look what we did back here. We said let x equal the sine of theta. Let's draw a little picture of that. So sine, it's the opposite side divided by the hypotenuse. So if you have, let's see, so if you have x equals sine of theta, well, here's what we're going to do. We're going to think of x as x over 1. Why would we do that? Well, we could think of this as the opposite side in a triangle divided by the hypotenuse. So if you draw a picture here, say, oh, okay, let's draw a triangle. Triangle with angle theta there. where the opposite side is x and the hypotenuse is 1. Now, using the Pythagorean theorem here, we can get the adjacent side. We can say, okay, well, we don't know this guy, the adjacent side. Well, we do know that the adjacent side squared plus x squared is equal to 1 squared. So if we solve for the adjacent side squared is equal to 1 minus x squared. We take square roots, and we get that the adjacent side is equal to plus or minus the square root of 1 minus x squared. But since theta is an angle between negative pi over 2 and pi over 2, we're looking on the right side here. So the adjacent side, well, it's always going to be positive, so we can actually ignore that negative possibility and say the adjacent side is root 1 minus x squared. So we can fill that in on our little diagram there. Why did I do this? Well, look in our problem. We have the cosine of theta here. We wanted to be able to simplify the cosine of theta. We'll look at our diagram. Cosine of theta, it's the adjacent side over the hypotenuse. The cosine of theta is root 1 minus x squared all over 1. So we have negative root 1 minus x squared all over 1. Or in other words, negative root 1 minus x squared. And then we got cosine cubed here. So we'll have negative root 1 minus x squared cubed all over 3 plus c. And that's our answer.